loop equation, you need to write it down. Okay. This is the second parameter of analysis. Yeah. Isaac, I want you the expression to be written. What would be the KBL? This is a closed loop, right? So for that, you need to write the KVL. Next one is the phase modulator. So how the phase modulator system approach. How the phase modulation is. This is the second parameter, right? First one we saw the closed loop gain. Now we are dealing with input impedance. Isaac, done with? Get something like this. Input voltage is equal to In plus K into A into In into Rn. Sorry, In into Rn is not coming there. And why? That has to come. It is based on the interference pattern. Okay, so the ultimate thing is your V by I should be 1. Sorry. V by I should be 1 plus Ka into V in into Rn. Okay, please keep this expression in your mind. This is very, very important because when you're doing for your 1 mark exams, you'll be given circuits and you'll need to evaluate what is your input impedance, right? So can I move to the next one? Next one is the output impedance. Okay, now output impedance, the resistance would be in series. This is the voltage gain. Okay. Now there are some rules which you should keep in your mind when you are taking the output intensity calculation. One is you need to nullify this value of input impedance. Okay, input this has to be made to 0 or grounded. Okay, so this part of the circuit gets completely negated. Now you need to find out what is the IX current. Okay, I'm externally connecting a Vx, okay, voltage source Vx, and I'm trying to evaluate the closed loop condition. Okay, so this is the thumb rule. I think we have already done with it for differential amplifier. We have seen how to calculate the input impedance. The same thing. You need to, the first thing is you need to connect an external voltage source Vx, okay, in which the Ix current flows, and then you nullify the sources. Okay, if it is a current source, then you open circuit it, and if it's a voltage source, then you make it into ground or 0, right? So based on that, this is nullified. Now you need to calculate what is the closed loop output impedance. Okay, so your I into R out. Okay, R out is nothing but this particular resistance is R out. Okay. Output resistance is R out is given to be Vx, this voltage, plus AK into Vx. That is nothing but this particular network value. Okay, so this would be the total value for the I. Okay, and the standard expression for your Vx by In is given to be R out by 1 plus K into A into Vn. Okay, so this is the thumb expression for output impedance. Okay, so when you look at it on the perspective of an open loop and closed loop system, how will you define it? Okay, now this is the output impedance. Okay, when you look at the closed loop system with respect to open loop system, first one, the gain. Generally, the gain is A. Okay, So this gain is the open loop gain. What happens to the value of gain when you brought it to a closed loop system? Is it increasing or decreasing? Ahatyan? Ahatyan? When you're comparing the gain for, yeah, between an open loop and a closed loop system, is it increasing or decreasing? Ahatyan? Isaac had told decreasing. Okay. Why Ahatyan? How do you say that? Is it increasing or decreasing? Ahatyan? Mr. Ahatyan? Is your gain increasing or decreasing?
Sir, I have network issues, sir. Can you please explain again, sir?
This is the condition for closed loop. Did you get that point?
Okay, sir.
Now, my question is, compared to open loop, the closed loop gain is increasing or decreasing? If the open loop gain A is equal to 100, then what is the closed loop gain if K is equal to 1?
50.
Yeah, it should be less. Okay, so what is the value of the gain in the closed loop? It is decreasing, right?
Yes, sir.
Justified? Now, what about the input impedance? Is it increasing or decreasing? Input impedance?
Increasing.
Increasing. Generally, the open loop input impedance is Rn, right? So there is another factor of 1 plus K into Vin is added. So the gain input impedance is increasing in a closed loop system compared to open loop, right?
Yes.
Now, what happened to the output impedance?
Decreasing.
Decreasing. So going to the ideal condition, it should decrease, right? So the open loop condition, the input impedance is higher, but when you divide it by 1 plus K into Vin, automatically the input, the output impedance is going to get decreased. Okay, so this is the three parametric analysis for a voltage feedback amplifier, right? Now we'll look up an example. Look at this particular example on the right hand side. Okay, now you have a op amp, okay, and it is connected back using an voltage divider bias concept. You have two resistance R1 and R2, okay, and there is a feedback element coming from here and it is going back, right? So this is the U element and this is the two comparator output you have. Okay, one is the input, the other one is the comparator input. You're comparing it, throwing an output. This is V out, right? So this is a basic circuit which is given to you. I think we've already seen the same circuit previously. So when you make the transistor version of it, so you have it's a common source amplifier. Okay, this is the input given, and then you have the two resistance, which is voltage divider bias, and the negative feedback is given here, right? So is this clear for everybody? So this is a what type of input? The input is V in, so the output is V out, and the feedback is given. So this is a voltage feedback amplifier, right? Is that okay for everybody? Now you need to calculate these parameters, right? Now over to Mr. Ashwin. Ashwin?
Yes, sir.
Is this clear, Ashwin?
Yes, sir.
Now, can you calculate what is the first parameter you need to evaluate for the circuit if you want to analyze? We saw there are three parameters, right?
Yes, sir. Closed loop gain.
Yeah,
Input
loop gain. Yeah, now can you calculate what is the gain?
gain.
How do you calculate the gain? What is the general expression for gain? We found out, right?
A by 1 plus K.
A by 1 plus K
K.
gain. So A for this particular transistor is what? A for this is nothing but this particular transistor's gain, right?
Yes, sir.
So you know what is the gain? Open loop gain is what? Minus GM into?
RD.
Yeah, that is known for you. Now
Yes,
you
sir.
need to find out what is the K value. Yes? So
Yes, sir.
open loop gain you can calculate. Open loop gain is GM into RD. Fine, done. Good. Now what about the closed loop gain? That is K into A you have to find out, right?
Yes, sir.
How do you calculate that? This is how you find out. Okay.
R1 by.
Yeah. Listen here. This is GM into RD is the open loop gain, right?
Yes, sir.
Now you need to find out what is the K value. K value is nothing but this is the feedback element, right?
Yes, sir.
Here you have an voltage divider bias. You have two resistance coming into play. So how do you find out the voltage divider bias concept? The R value, R2 divided by R1 plus R2.
Yes, sir.
This is the resistance under closed loop. So this is R2 divided by R1 plus R2. So the voltage divider bias concept, right? So when you put that across, it becomes GM into RT. This is KA. Okay. KA is nothing but R2 divided by R1 plus R2. Okay. K is nothing but R2 divided by R1 plus R2.
Yes, sir.
A is GM into RT. Is that fine?
Okay. Yes,
Now,
sir.
can you calculate the closed loop gain and tell me? Can you calculate what is the closed loop gain and tell me? All of you. Calculate the closed loop gain and tell me. I've given you what is K into A. You have to evaluate the closed loop for this particular circuit.
The mass, power, temperature. So the measurement is nothing but the physical quantity that is subject to measure. Physical quantity that is subject to measure. So here this is the general block diagram of the fiber optic sensor.
Ahatyan, you have to tell the answer because I don't have the answer for it. Anybody else done it?
General introduction of the fiber optic sensor. You understand? Everyone?
You have to substitute it into this expression.
Yeah.
Yeah, go ahead, make it fast.
Yeah. Actually, after the transducer, this is the general block diagram. Actually, after the transducer, okay, we have another component. Okay, so when it is converting the light signal into the electrical signal, okay, it is the receiver section.
Isaac, it is GM
It
into.
is the receiver section.
Just check it out.
Okay,
Sorry, I don't have the answer.
we have an electrical amplifier.
Hopefully, it's right. Did you get this? What Isaac has done is right. GM into RD into 1 by 1 plus. It is. I hope it is GM. GM into RD into R2 by R1 plus R2. Is that right, Mr. Ashwin? Is that right? What Isaac has thrown?
Time, sir. Not it.
Okay, make it fast. Make it fast. I'll give you 2 minutes.
But when I was teaching it in the first unit, we have the modulation process in the transmitter section and demodulation process in the receiver section. Here, the detector that is used is nothing but the reduction of the optical signal.
Anybody else with Francis?
Yes, sir. Same.
Same, eh? Right. It's not GR. I mean, it is GM. Typo error, I think.
Yes, sir. GM.
I think it's GM, not RM. It's typo error. Yeah. Fine. No problem. Good, Isaac. Good. Almost. Thank you. Ashwin, you reached
Yes,
there?
sir. Yes, sir. Same answer, sir.
Fine, right. Thank you. Now we'll go to the next one, Ashwin. What is the next parameter?
Input impedance.
Input impedance. Now, how do you calculate what is input impedance? You know what is the expression.
AINRN.
Yeah, your input impedance should be 1 plus K into A into V in by into Rn, right? Now you should know what is your Rn. What your Rn?
Sir.
What is your Rn?
RA.
Rn is 1 by Gm.
Yes, sir. Yes,
Okay,
sir.
into 1 plus, because it's only a resistance, right? It's only a transistor you have. So the input resistance of this particular thing is nothing but the internal resistance of this particular transistor. That is 1 by Gm. Okay, so that is going to be the input impedance of this thing. So this is Rn. So you know what is Rn. I think the rest of the parameters are all known for you. You know what is the expression for your V in. That is nothing but 1 plus K. You know Ka you already know. So then just solve substitution. I think you should get something like this: 1 plus Gm into Rd into R. This is not
D1 into RD1 by R.
R2 divided by R1 plus R2.
Hmm.
Is that right, all of you? I think is that right? Let's check it out. That's the closed loop input impedance, or input impedance or input resistance. It's impedance. GM is that.
That allows to pass through the light pulses will be collected in the detector,
Is that fine, Atin?
and then it is processed in the electronic processing. Okay, so first one is
1
once
plus
the signal
RD2.
is received, it is converted into
What is that? Atin, you're given something I didn't
Then
understand.
the modulated signal is converted. Yes. If it is not sharper.
GM into RD into R2. That's it, R2. It's R2 only.
Yes. So here you can see the source is produced in the light pulses.
Okay.
That light pulses is propagated.
All of you got it?
The light pulses is
Akshaya?
electrical signal. Once the electrical
Akshaya?
signal is converted, it is
Sorry, Ashika. Is it right? Okay, fine. Now we'll go to the next one. The last one is the output impedance. The output impedance is what? You should know what is your R out. What is R out, Adit? Sorry, Ashwin? You just need to know what is R out. What is R out?
Sir, R out.
There's nothing but your this value.
RD.
Your RD. Okay, RD is your R out. So RD divided by, what is the expression?
1 plus
1
GM.
plus K into A is already known for you. That's it. Substitute. That's all. The rest are all same. Is that fine? So you can calculate for any given circuit. Okay.
Yes,
Ashwin is fine?
yes, sir. Yes, sir.
Thank you, Ashwin. Right, over to Mantino. Mantino? Mantino will go to the next example. Okay, I don't have answers for anything. This is the unity gain buffer. Okay, I'm having a buffer. Is that okay, Mantino? Is it audible? This is a buffer, right? So I have an input A, right? And then I feed back it into the next element. Okay, and the feedback element, I don't have any resistance here, so I'm just having a loop wire. So this loop wire is fed back to this particular element. So the input is V in, output is V out. So this is a voltage feedback scenario. Is that fine, Mantino? He's absent, huh? He's present, right?
Yes, sir.
Mantino, is this okay?
Yes, sir.
The circuit is fine?
Yes, sir.
Now, can you calculate what is the gain?
Okay, sir. Calculated, sir.
Just calculate what is the
usage of the optical pulses. So once the electrical signal is converted into the optical pulses, it is detected by means of the detector and it is processed with the electronic signal for a noise-free or a distortion-free optical pulses, because the optical pulses are traveling.
now you have two elements in it, right? In a feedback system, Mantino. One is the feed forward. Yes, the other one is the feed backward. Now, feed forward is what? The feed forward is what is given in this A. You see the dotted line, right? That is what is the feed forward element. This whole thing is the feed forward element. Okay. The feed backward element is there's only one wire down there which runs across this, right? So they'll give only this thing. You have to draw this thing. Okay, so ensure that you draw it clearly. Now you need to find out what is the gain. How do you calculate the gain?
The same light source.
How do you calculate the gain?
Here the signal is given as an input.
You no need to calculate the value of k because k is already given to be 1. Okay, you just have to find out what is a. Once that is done, you are done with the expression.
This is the intensity modulated sensor. This intensity modulated sensor is used to detect the amount of light. It is used to detect the amount of the light. For example, the light from the light source is intensity modulated by the signal.
What is the gain,
We are getting the
Mantino?
light signal from the light source and is modulated by means of the modulator.
Sir, 1 minute, sir.
By means of the modulator. So here you can see the light from the source is intensity modulated by the signal or perturbing environment. Okay. And then it is detector. Okay. So once the light is detected, so here you are having the light detection. Okay. So the light from the source is intensity modulated by the signal or with respect to the environment.
Hey, there's nothing too big over here, man.
After the modulation, it is detected. So
Yeah,
whatever
just
may
got
be
4
the
minutes more. Make it faster. Mantino,
there may be the loss
Mantino, what is the gain
to the
of
transmission
this
of the
particular
light,
amplifier?
reflection of the light, bending of the light, absorption of the light. So all this
Sir, A by 1 plus A, sir.
Pardon?
bending of
A by 1 plus A.
What is this A? I want the A only to be known. What is A?
and finally it gives the output
We need the gain, right?
signal.
Yes,
And
sir.
what transistor you have? You have on 2 transistors over here, for which one of the transistors is going to be given the input, right?
Okay,
This
sir.
M1 transistor. Okay. Now this transistor is given an input, right?
Yes, sir.
This is your M1 transistor. Now this M1 transistor, how do you calculate the gain of this transistor? You have a resistance here, RB, right? Now
Yes,
how do you
sir.
calculate the gain of this transistor? We have seen it 101 times. How do you calculate the gain?
Which is converted and modulated by the
What is the gain of an amplifier? That's all matter. No? A is equal to
this is what is called as the
GM into
RM.
GM1 into RD.
Yes, sir.
Okay, so that's all. That's the gain of an amplifier. So, so that is for A. For closed loop, then what will be the value?
and whenever it is detecting, it detects with the losses.
How do you calculate the closed loop?
Detector may have the
What is the
losses of
expression?
transmission
We've already seen
and the losses of reflection and the
A
losses
by
of microbending and the
1 plus K,
1
sir.
plus KA. So what is A?
detector signal will
GM into RD.
RD.
1 plus what is the K value?
1, sir.
1. So what is the expression?
GM into RD by 1 plus GM into
GM
RD,
into
sir.
RD. That's all. Very good. So all of you, is that clear? So that is the expression for the closed loop gain. Okay. Now I don't have the typing screen. I cannot write it. Okay. All of you, is that clear? Mantino, give it in the chat, ma. So others can know that. Type it in the chat. The closed loop gain. Right. So is that clear, all of you? The closed loop gain. Just check you got the same thing. What he has got, GM into RD divided by 1 plus GM into RD. K value is 1. That's already given. Thank you, Mantno. Right. Now let's go to the second parameter. What is the second parameter, Mantno? Second parameter is closed loop. Closed loop. What is the second parameter? Mantno?
Input parameter, sir.
Yeah, input impedance. Now, how do you calculate the input impedance, closed loop input impedance? So, for closed loop input impedance, you have to look at the circuit from this particular point of view. This is the input side, right? So, closed loop input
sir.
impedance, what would be the value? We already seen for the previous circuit. How did you calculate? How did you calculate the input impedance? Input impedance is nothing but Rn. You need to calculate Rn alone.
Yes,
Ka
sir.
you already know. You know what is K, what is A. So what is going to be this value? The input impedance of this circuit is given to be 1 by GM1.
GM in,
Okay, previously we have done 1 by GM1. So 1 by GM1 is the Rn. So how do you calculate what is the input impedance of a closed loop? What is the expression? Input impedance expression is what? 1 plus Ka into Vin. Ka you already calculated.
yes, sir.
So substitute it. Tell me what is the expression.
Okay, sir.
What is the expression for this particular circuit? For input impedance. Can I have Mr. This other person, Joel? Joel, type the expression now for input impedance. It's very simple. Your in Rn is given to be 1 by GM1. So what would be the expression? Fast. Joel, write the expression fast. We are running out of time. Right, Mantno over. What is the third parameter, Mantno? With that, we'll conclude. Third parameter is Mantino finished. Input impedance. Yeah, we'll give it to Joel. Joel, you've finished the input impedance calculation?
I'm working on it, sir.
Working on it. Nothing to work, man. Already there. Yeah, one of you can type the input impedance. We can go for the next one. So others can have a reference. Mantino, over. Mantino. Can we go to the next one? Mantino, the last one.
So, one
This
second.
is the third parameter. Yeah, make it fast.
Yes, sir.
What is the third parameter? We have the third parameter as the output impedance. Perfect. Write the expression, man. Please give the expression so that it can be a reference for other people's.
Already he wrote, sir.
Uma.
Agatya.
Agatyan. Is that the same thing? RD into
Yes.
1 plus GM into.
Yes, sir.
Thank you. Thank you, ma. Okay, we'll go for the next one, the last one. Output parameter. So, output resistance, Mantino. This is the output, right? For output resistance, you need to calculate what? What is the expression for output resistance? R out divided by 1 plus K into Vn, right? So you need to calculate
Yes,
what
sir.
is R out. What is the R out of this expression? For this circuit, what is the R out? Looking at the circuit, what is the R out? Fast. R out is nothing but 1 by GM2. Okay, that is the output for that particular circuit, right? Second transistor. The input impedance was 1 by this particular transistor for first transistor. Okay, for the first transistor. So for the second transistor, your resistance output is going to be this particular transistor, that is M2 transistor. Okay, this transistor's output impedance is the R out. So this is going to be 1 by GM2. So 1 by GM2. So that is the R out. Just substitute it. Calculate what is the closed loop output impedance. Now to know output expression now. It should be 1 by GM2 into 1 plus GM1 into RD. Did you get that? Yes, all of you? 1 by GM2 into 1 divided by 1 plus GM1 into RD. Right? So these are the three parameters of analysis. So they can give you any circuit like this. I will post you some 2 circuits, one application circuit also, I'll give it to you. You can work it out and tell me what is the output. Okay. Mando, is that clear? So we have studied today's class about what is the voltage feedback amplifier basic structure. Then we have analyzed voltage feedback amplifier with respect to voltage gain, input impedance, output impedance, and then we saw 2 examples of how to evaluate these parameters using the closed loop system. Okay.